Functions. What are functions? Well, a function is basically if we put a value of x into our mystery black box, we'll call it our f of x box, our function box, it gives us out one distinct y value. It cannot be multiple y values. There's no y2, y3, etc. That is not possible for a function. If I have multiple y's from a given x input, I don't have a function. And we'll see how that tests out graphically in a second. So what exactly is a function? We see y equals f of x. Well, our f of x is more or less our y value whenever we input x into our function. So we've seen that before. It could be y equals 2x plus 2. That essentially means take whatever the x value is at a given point, multiply it by 2 and add 2 to that. And that will be the y value on your xy coordinate point on the Cartesian coordinate system if we're graphing it. So what's special about a function? Well, we're not going to be tested on whether you have a function or not on the exam, but we will see problems that will ask for y in terms of x, like we see here. But nevertheless, you should understand the technicalities of what a function is. A function is not merely the y value for a given x input. A function has to adhere to a definitive input produces a distinct output, not multiple outputs. Well, graphically, that's essentially what you may know is the vertical line test. Again, not something that's directly going to be tested on your exam, but you should understand it. That means over the domain of my function, which suppose I have a circle here. This might represent x squared plus y squared equals 1. That would be the equation of the circle shown, with radius 1, with the center at the origin. If I can pass a vertical line through any point and every point in the domain, i.e. where the graph exists over the range of the x-axis, if there's only one intersection, I have a function. In other words, I only have one y output for an x. Problem here, at negative, call that 0.6 there, that line, that vertical line passes through two different points. It's not a function. There are two y outputs for a given x input. In fact, we see a circle is not a function. It fails our vertical line test. It has more than one intersection pretty much everywhere over the domain. Well, what about, say, a line? What if I had a line? Is that a function? A line, if I pass vertical lines anywhere where my line exists across the x-axis, its domain, there's always only one intersection. So that passes, it checks our vertical line test. A linear equation is a function. And that's technically how we define a function and what it is. Imaginary functions, they are so cool. Yeah, they are. And the reason why they are, because they appear on the exam a lot. You will be tested on imaginary functions. So what exactly is this problem? What's going on? A at B. What is that? I don't know what that symbol is. At, what the heck? I know what some operations are, like multiplication, division, addition, subtraction, squaring, taking the square root, so on and so forth. But what the heck is at? Well, it's an imaginary function. I'm making it up. I'm defining it here. If I have some value before the at symbol, and then some value after it, it basically says double the value after the at symbol, the b, which is after my operator, my at, and subtract from that 3 times the value a, which is the value before that operator, the at symbol. Okay, so let's see that at work in an example. 2 at 3, what would that be? That would be 2 times what comes afterwards, so 2 times the 3 minus 3 times the value that comes before the symbol, which is 2. This is 6 minus 6, or 0. The answer to 2 at 3 is 0. That's how we deal with imaginary functions. We essentially create the definition right there, and we use it to evaluate whatever values we are given for the variables. So let's try something else. What about x at y? Now see, I can imagine or make up any symbol I want. I thought that looked kind of cool, right? Let's suppose we say that is x squared minus y squared. That's what x at symbol y means. All right, well, what if I had an actual value for that? What would that be? 5, whatever that symbol is, 4, basically means square the 5, the value before the symbol, subtract from that the square of the value y that comes after the symbol, 4 squared in this case, and what we end up with is 25 minus 16, which equals 9. So 5 at 4 evaluates to 9. And that's what most of the problems will ask you to do. You'll be given a defined imaginary function, and you will have to evaluate it. Now be very careful. You have to remember all those fundamental basic rules, especially PEMDAS, our order of operations, as well as the associative, the commutative properties. They all apply to imaginary functions as they do in algebra in general. Let's see that at work in another function. Suppose I had m, some symbol, my imaginary function symbol, n. That means 3 times the quantity of the first value before the symbol plus 1 squared divided by the second value after the symbol. So, all right, well, what would, say, 3 symbol 1 be? In this case, it would be 3 times my m, the value before the symbol, 3 plus 1, that quantity squared, divided by my n, the value after the symbol is 1. Well, okay, I have to do my order of ops. I have to evaluate the parentheses first. So it's going to be 3 plus 1 is 4 squared over 1. Now I'm going to evaluate my exponent next. 4 squared is 16. 3 times 16 divided by 1. Now I have multiplication and division, which are evaluated at the same order, essentially left to right. So it's 3 times 16, 48, divided by 1. The answer is 48. Again, be careful to watch your PEMDAS. All right, what if I had embedded functions? Y star z equals 2 times y plus 2, the value before the star, divided by z, the value after the star. Great, I think I understand that. What if I'm given 3 star parentheses 5 star 2? Well, okay, there's an embedded function. Again, I first need to do the parentheses. That's what I'm going to evaluate. 5 at 2. So let's kind of look at that up here separately. 5 star 2 means 2 times the value 5, what comes before the star, plus 2, divided by z, the value after the star, which is 2 in this case, right? So that equals 10 plus 2. Essentially, my numerator is in parentheses, so I'm going to evaluate that first. That's 10 plus 2 is 12 divided by 2. That's 6. All right, I can take that and plug that back into the rest of my function. I started with my parentheses. I evaluated it to 6. Now I have 3 star 6 to evaluate. Well, I know that. It's the same exercise. I'm just going to do it over with the new numbers. It's 2 times the value before the star, which is 3, plus 2 divided by z, which in this case, the value z that comes after the star is our 6. So I divide by 6. 2 times 3 is 6 plus 2 is 8. Divided by 6 is 8/6, or 4/3. My final answer for the embedded imaginary function, a format you'll often see, is 4/3.